Hola y bienvenidos a video número 3. Un momento, por favor. Okay, that's better. Welcome to video number 3 on the polynomial lessons here. I started off with a warm-up about end behavior from yesterday. If you could try this on your own now, try to describe the end behavior of the graph of what this equation would look like. Go ahead and give that a shot now. Okay, you're back. Remember that in order to do end behavior, you have to have your polynomial written in standard form first. So before we jump in and say, oh, I see the lead coefficient, I see the degree, remember that this has to be simplified and put in simplest form and put in standard form. So we see that x to the third power is really going to be our degree. So we have to first rewrite this. 2x cubed out front. We have 2x squared terms to combine to give us a negative 4x squared, and then just rearrange those terms so our constant comes last. This is the standard form polynomial we should be looking at to figure out our end behavior. We have our degree. Our degree is 3. It's our largest exponent. Remember, what matters about that is that our degree is odd. All right, so we have an odd degree. And we have that chart yesterday that you could flip back and look at in your guided notes, but I don't want us to have to rely on that chart. I want us to be thinking about big idea patterns here. That when we have an odd degree, we think about the simplest odd degree polynomial, and that's just an x to the first power. That's just a linear function. So the ends of this graph will resemble the ends of a linear function. In this case, since our lead coefficient is positive, a positive 2 for our leading coefficient, we think about a positive sloped straight line. So the ends of the graph should resemble the ends of a positive sloped straight line. Now the way we write those statements, remember we talk about each of those ends individually. What's happening is x is getting very, very large. So what's happening as x approaches infinity, well, if my ends are pointing like this, as x is getting larger, so is y. This end's pointing up. So as x approaches infinity, y approaches infinity. Now as x approaches negative infinity, think about the other end of that straight line. The y values, as x gets more and more negative, the y values also get more and more negative. So y is going to approach a negative infinity there. Remember, when you describe end behavior, you'll always be giving two statements. What happens as x approaches positive infinity? What happens as x approaches negative infinity? All right, so that's a little reminder of end behavior, and we'll be looking at later on how to fill in the middle of those graphs also. How we can figure out what the characteristics of the other parts of that graph would be and not just the ends. What I want to talk about today is, now that we know what a polynomial looks like, how do we do some algebraic things with polynomials? How do we add and subtract polynomials? How do we multiply polynomials together? The good news is all three of these things, addition, subtraction, multiplication, all build on skills that you are familiar with already. You know, if I said, here's two polynomials to add together, I just want you to just take your best shot here without me teaching you anything. Chances are you would do the right thing here. What you're doing when you add polynomials or when you subtract polynomials is simply combining like terms. So you're really doing the same thing that we did when we put polynomials into standard form. So in the case of the addition problem here in blue, we see, well, I have 4x cubed and I'm adding a 2x cubed. That just becomes 6x cubed. I'm adding 7x squared. I'm adding a negative 4x squared, so plus 3x squared. I have a negative 2x. I'm adding a 9x, so plus 7x. And then finally, negative 5 plus a negative 3 would give me a negative 8. Notice that polynomial is written in standard form. We would always want to write our answer in standard form. So if we needed to rearrange some terms to make that happen, we would do so. But that's all there is to adding polynomials together. It's also all there is to subtracting polynomials. The thing you have to be careful about when you subtract polynomials is you don't lose track of signs along the way. I'll show you what I mean. The same two polynomials here that I'm trying to subtract. So I first look at my x cubed terms. I have a 4x cubed minus a 2x cubed, and that would give me a 2x cubed. Now here's where you have to really start being careful. We have a 7x squared. We're subtracting a negative 4x squared. So it's really 7x squared minus a negative 4x squared. So it's like 7x squared plus 4x squared. So this becomes plus 11x squared. Okay? negative 2x minus a positive 9x. Negative 2 minus 9. Give us a negative 11x. And then negative 5 minus a negative 3. Or like negative 5 plus 3, or negative 2. And so this is what your simplified polynomial, the difference of those two polynomials, would be. Be particularly careful in subtraction about those signs. When you're subtracting a negative or subtracting a positive, make sure you're keeping those correct. One thing that people sometimes like to do, I'll show you, if you have trouble keeping track of those signs, go ahead and start the problem by distributing this minus, this negative, through this entire polynomial and rewriting it like this. So, okay, well, I have this first polynomial sitting here as is. Then I'm subtracting 2x cubed, and I'm subtracting a negative 4x squared. So I could think of this as a minus a negative, or plus 4x squared. Minus a positive 9x, so I could do minus 9x there. And then minus a negative 3 would make this a plus 3. Some people like to do that because by getting that negative sign distributed through there right away, it just turns into putting a longer polynomial in standard form. Now we're just combining like terms, 7x squared plus 4x squared, negative 2x and a negative 9x, negative 5 and a positive 3. So just a couple different ways you can handle that. If you're okay just subtracting term by term as you go, that's fine. If you'd rather distribute that through there first, that's fine too. That's all there is to adding and subtracting polynomials. So let's talk about multiplying polynomials a little bit. The good news is we've already multiplied polynomials before, just specific types of polynomials. And that first example that you see there has two binomials, two polynomials that have two terms each, x plus 3 times x plus 5. And we've multiplied things like this a lot. We've called it FOIL before. We really know that FOIL is just a shortcut way to say we're doing the distributive property, right? We're taking an x and we're distributing it through here, x times x to get x squared, and x times a positive 5 to get a plus 5x. And then we're doing the same with the 3. We're doing plus 3 times x, and we're doing a positive 3 times a positive 5. We're combining like terms, and notice we were putting this in standard form back then. When we made the 5x plus 3x and combined that to give us 8x, we always wrote our answers like this, which is standard form, right? Largest exponent up front, everything simplified. So what we did there by doing FOIL, or the distributive property, is all there is to multiplying any polynomial. Right? So if I want to multiply these two polynomials together, I'm just doing the distributive property over and over again, one term at a time. So in this problem, I'm starting by distributing the x all the way through this polynomial. I'm going to multiply x by each of these things. X times x squared. Well, that'd be x to the third power. X times a positive 3x would be plus 3x squared. And then x times a negative 5 give us a minus 5x. All right? Distributive property. Now I'm going to do the distributive property again with the minus 4. I'm going to take a negative 4 and I'm going to distribute that through that same polynomial. I'm going to do negative 4 times x squared. A negative 4 times a positive 3x. And a negative 4 times a negative 5 gives me a plus 20. After I multiply, after I distribute, I'm going to put this in standard form. I'm going to get all my like terms combined. I'm going to put the largest exponents out front. So my x cubed, my degree is going to be 3 here. 3x squared minus 4x squared, so negative 1x squared. We just say negative x squared there. Negative 5x minus 12x, negative 17x. And then a plus 20 on the end. So when we multiply, we're putting our final answer in standard form. Just like we put our answer in standard form back when we were multiplying binomials, back when we were just talking about quadratics and parabolas. Right? So multiplying polynomials just comes down to doing the distributive property more times because there are more terms to distribute through. Right? On the next board here and also on your study guide there and your notes, I have one that I'd like you to try on your own. So if you'll go ahead and try to multiply those two together. We'll edit that out, don't worry about it. We can't edit. We'll leave that in, all right? You'll just multiply these two together on your own, pause it, give it a shot, and we'll look at it. Okay, so you're ready to distribute. We're going to start by multiplying the x cubed all the way through. X cubed times 6x to the 5th. Remember, when we multiply, we add exponents, so this is going to become 6x to the 8th. X cubed times a negative 2x cubed minus 2x to the 6th. And then x cubed times a positive 9. 9x cubed there. Okay? So we have our first three terms of our product. We multiply these. Do the same thing multiplying the 4x through. 4x times 6x to the 5th. Again, you're adding exponents. Remember, this is x to the 1st. So when we multiply, we've got 24x to the 6th power. 1 plus 5 for your exponent. 4x times a negative 2x to the 3rd. Negative 8x to the 4th. And then 4x times a positive 9 at the end. Give us a plus 36x. So we end up with 6 terms, but we're going to simplify that. We're going to put it in standard form. Looks like a couple of those will combine for us when we do that. Get our exponents in order. We've got an 8th degree polynomial here, even degree. So if I tried to graph this, the ends would positive 6x to the 8th. The ends would point like that. Y would approach infinity in both cases. So this is 6x to the 8th. Now, I don't have any 7th degree terms, so I move down to the 6th. It's going to combine to be 22, x to the 6th. And then nothing else combines. You've got a minus 8x to the 4th, plus 9x to the 3rd, plus 36x. And I think that's the best I can do as far as simplifying that polynomial down. So again, multiplying polynomials just comes down to doing the distributive property and simplifying things. Okay, so now we know how to add and subtract and multiply polynomials. We haven't talked about division yet. Division's a little bit trickier. There are a couple different ways I want to show you how to divide polynomials. We're going to save that for some later videos. Adding, subtracting, and multiplying should be plenty for today. Hopefully this made sense. We'll work on this in class tomorrow.